Number 7. The flat edge. In 1980, physicist Alan Guth was studying the geometry of the early universe when he confronted a problem that should not have a comfortable answer. The universe is flat, not curved inward like a sphere, not curved outward like a saddle, flat to within a fraction of a percent. And for it to be this flat today, the density of the early universe had to be balanced against the rate of expansion with almost perfect precision. The numbers are not gentle. In the first instant after the beginning, the density of the universe had to match a critical value to within 1 part in 10,000 trillion 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 trillion. A hair more, and the cosmos would have collapsed back on itself before a single star formed. A hair less, and it would have expanded so fast that matter could never clump into galaxies. It landed exactly on the edge. What makes this balance particularly unsettling is that there was no reason for it. Nothing in the equations forces the universe to be flat. It is a setting dialed to an impossible degree of accuracy with no mechanism that demanded it land there. You exist because the universe threaded a needle in its first fraction of a second. Too heavy, and there is no you. Too light, and there is no you. The window was vanishingly thin, and reality walked straight through the center of it. The truly unsettling aspect is how this looks from the outside. A coin balanced perfectly on its edge does not stay there by accident, and somewhere in the first instant of everything, the universe was set spinning on that edge, and it has not fallen since. Number 6. The strong lock. Freeman Dyson spent decades studying the forces that hold matter together, and somewhere in that work he noticed something that disturbed him. The strong nuclear force, the glue binding protons and neutrons inside every atom, is tuned to a value that allows complex matter to exist at all. Shift it by a few percent in either direction, and the universe becomes a wasteland. The core of the problem is balance. If the strong force were just a little stronger, protons would have fused into one another in the early universe, leaving no hydrogen, no water, no stars that burn for billions of years, no fuel for life. If it were a little weaker, no element heavier than hydrogen could hold together at all. Either way, the universe ends up empty of everything that matters, but the implications run deeper than a single force. The strong force does not sit alone. It is balanced against electromagnetism, against the masses of particles, against the weak force, each one tuned, each one resting in a narrow band, all of them holding the same fragile arrangement that makes atoms possible. You are made of atoms that should not be this stable. Every carbon atom in your body, every iron atom in your blood exists because a single force was set to a value with no margin for error. Move the dial and you are not sick. You are impossible. What Dyson could not have known is how the list would grow. The strong force was only the first lock anyone noticed. The truly chilling part is that every force we have measured since has turned out to be locked the same way. Set, precise, and silent about who said it. Number 5. The carbon key. In 1953, astronomer Fred Hoyle made a prediction so bold that most of his colleagues thought he had lost his way. He was trying to understand how carbon, the element every living thing is built from, could form inside stars. The standard physics said it almost never should. So Hoyle reversed the logic. Carbon exists, he reasoned. Therefore, there must be a hidden resonance in the nucleus that lets it form. He predicted its exact energy, and when they tested it, he was right. His discovery, now called the Hoyle resonance, revealed that carbon-12 has an energy level tuned with extraordinary precision to allow 3 helium nuclei to fuse inside dying stars. Without that exact resonance, the chain breaks. Carbon never accumulates. The universe fills with hydrogen and helium and almost nothing else. No chemistry, no biology, no possibility of anything that thinks. What makes this particularly haunting is Hoyle's own reaction. He was not a religious man, he was a hardened skeptic. And yet he wrote that the tuning of carbon looked like a put-up job, as if a super intellect had monkeyed with the laws of physics to make life possible. You are a carbon-based structure. Every cell, every strand of you, was assembled from atoms forged in stellar cores through a resonance that did not have to exist. The key fit the lock perfectly. The truly haunting aspect is who cut the key. Hoyle measured the resonance, he confirmed it. And somewhere in that measurement, the most committed skeptic of his generation found himself staring at what looked unmistakably like intent. Number 4. The water exception. Some chemists have argued that the strangest evidence is not in physics at all, but in a single ordinary substance. The most complete version comes from Lawrence Henderson, who in 1913 published a study of why the environment itself seems suited to life. His focus was water, a molecule that breaks the rules of chemistry in exactly the ways living things require. Water should behave like similar molecules. It should freeze from the bottom up, killing every lake and ocean each winter. Instead, ice floats, sealing the water below and letting life survive. Water should be a gas at the temperatures we live in. Instead, it stays liquid. It dissolves almost everything, carries heat, resists temperature swings, a list of anomalies so long that each one individually is exactly what biology needs. The disturbing part is not the theory itself. It is what the theory demands. Either every one of these anomalies is a coincidence stacked on top of all the fine-tuning in physics, or the environment was as prepared as the chemistry that fills it. But not everyone sees design here. Many physicists reject the whole argument as backward reasoning. We notice the tuning, they say, only because we are here to notice it. Survivors describing the one universe that allowed survivors. In an endless multiverse, ours is simply the lottery ticket that won, and dead universes have no one to marvel at how dead they are. The mathematics leave no room for comfort either way. If they are right, we are one lucky draw among countless corpses. If they are wrong, someone prepared the water before we arrived. Number 3, the entropy miracle. Roger Penrose spent decades working on the deep structure of space and time, and in 1989 he calculated a number so large it breaks the mind. He asked how precisely the universe had to begin in order to produce the ordered cosmos we see. A universe with a low entropy past, where stars and galaxies and life could emerge instead of formless heat. The answer was the most extreme fine-tuning ever found in science. The number is 1 part in 10 to the power of 10 to the power of 123. It cannot be written out. There are not enough particles in the observable universe to print the zeros. Penrose's point was simple and devastating. The beginning of the universe was selected from the space of all possible beginnings with a precision that has no parallel anywhere in physics. What makes this particularly terrifying is the contrast. A messy high-entropy beginning was overwhelmingly more likely, almost infinitely more likely. The universe could have begun as a uniform soup that never formed a single structure. Instead, it began in a state so ordered, so improbable, that calling it chance strains the word past breaking. You owe your existence to the single most precise act in the history of everything. Every star that ever shone, every moment you have ever lived, rests on a beginning fine-tuned beyond any number the human mind can hold. The truly terrifying aspect is what precision implies. Random processes do not produce 1 part in 10 to the 10 to the 123. And somewhere at the start of time, that number was set, not approached, not approximated, but set. And nothing in physics explains the hand that set it. Number 2. The vacuum number. In 1987, physicist Steven Weinberg confronted what many consider the worst problem in all of science. Empty space is not truly empty. It carries energy, a background hum of the vacuum itself. When physicists calculated how much, the answer came out wrong by a factor so vast it became infamous. The prediction missed reality by 1 part in 10 to the power of 120. The core of the disaster is the cosmological constant. If the vacuum energy were even slightly larger than its measured value, the universe would have torn itself apart in the first instant, ripping space so violently that no atom, no star, no structure could ever form. Slightly negative, and the cosmos collapses before it begins. The value that allows a universe to exist sits in a window narrower than anything else ever measured. Strip away the mathematics, and what remains is nightmarish. This is not a force tuned to a few decimal places. This is a number balanced to 1 part in a quantity with 120 zeros. The difference between a universe and instant annihilation, resting on a knife edge no theory predicted. You live inside the one setting that did not destroy everything. The vacuum could have ended reality before the first second. It did not. It held at exactly the value that permits a cosmos slow enough, gentle enough, stable enough for galaxies to gather and minds to wake. And there is no escape from the conclusion. Weinberg, a lifelong skeptic of design, admitted the value looked tuned for life. The worst prediction in physics is also the clearest fingerprint we have ever found. Number 1. The tuned observer. Some cosmologists have asked the most dangerous question of all. Not whether the universe is tuned, but what it is tuned for. The most precise version comes from Brandon Carter, who in 1973 formalized what is now called the anthropic principle, the unsettling observation that every fundamental constant seems balanced toward exactly one outcome, the existence of conscious observers. This is where Carter's work crosses from physics into unnerving territory. Each fine-tuning we have found points the same direction. The flat universe, the locked forces, the carbon resonance, the impossible entropy of the beginning, the vacuum balance to 1 part in 10 to the 120, none of them are tuned for stars alone or atoms alone. They are tuned, collectively, for the eventual emergence of minds that could one day look up and notice the tuning. The cosmos was set across every dial to produce something that observes it. Remember the entropy number from number 3? 1 part in 10 to the 10 to the 123? Now stack it against every other coincidence on this list. The probability that all of them aligned by accident does not shrink. It vanishes. And what is left when chance vanishes is a word physics does not want to say. You are not a byproduct of a careless universe. You are the apparent purpose of an exquisitely prepared one. The observer the constants we're waiting for. Every law was set so that billions of years later, you would exist to read this sentence. We will never confirm this, but we will never disprove it either. The tuning is real, measurable, repeated across every constant we test. The intent is invisible, and somewhere behind every dial, set with a precision no accident can explain, whatever did the tuning left exactly one message. The universe itself, and then made certain it would never be found. If you want to see more videos like this, click the video on screen now and make sure to subscribe.